Okay. I love this. When finding the derivative at a point, there are two approaches. You can either find the general formula first and substitute your x value, or you can substitute the x value from the start. All right, and we've looked at both of those. I did both of those in class, so that was pretty good. If you're given 1 point, you're finding instantaneous rate of change, the slope of the tangent line, the derivative, and then this is the formal definition of the derivative. All right. If you're given 2 points, you're finding average rate of change, all right, the slope of the secant line, and then just your old school y2 minus y1 over x2 minus x1. Okay. Now, this is cool because I should get the same answer on A and B. They're both the same thing. All right. So it says find the slope of the tangent line using the alternate form or the original form. All right. Then let's see the difference. All right, same answer in the end, but different ways of going about it. All right, so here we go. Let's do this. All right, so this is going to be the limit as x approaches, is the alternate form they call it, as x approaches 3 of f of x minus f of 3 over x minus 3. Okay, and we might as well call this what it is. This is going to be f prime of 3, the slope of the tangent line when x is 3. Okay, so let's substitute in then. So I've got the limit as x approaches 3 of the function, which is 2 over x, minus 3 substituted in, 2 over 3, over x minus 3. And of course, I can't substitute 3 in just yet, because if I do, then I've got the same fraction minus the same fraction, which is 0. And on the bottom, of course, 3 minus 3. All right, so what do we do? Well, we need a common denominator. So up top, the common denominator is going to be 3x. I think I'm going to do this. So I'm going to do the common denominator of 3x. And off to the side, I'm going to have this be 1 over x minus 3. So that's just kind of, that division is saved for later. And then here, we'll have, this is going to be 6. So multiply top and bottom here by 3, which is 6, minus top and bottom of here by x. Okay, that looks great. All right, so then this will be the limit as x approaches 3 of, what's this little factoring trick here? I'm going to factor out a negative 2 so that I'll have an x minus 3 that'll cancel that one out. So a negative 2 so that I have an x minus 3. There's another way to think about that, and I'll bring that back in just a second. Okay. All right, so then if I go that route, then now the x minus 3's cancel. And that gets rid of our 0 over 0. So now I can do a substitution. My numerator will be negative 2. And in my denominator, I'll have to substitute the 3 in. 3 times 3 is 9. Now, here's what I was about to say, if you can kind of see it. I could cancel these two out right away if I know that dividing those two would give me a negative 2. This is negative 2 times that. Just another way to do it. I don't know. To me, I kind of like this because that's what I'm used to. But if you can see that division happening, that both of those multiplied by negative 2 would give me that numerator, then dividing it, therefore, would leave you just with the negative 2. That's another way to go about it. All right, so negative 2/9. Okay, so that one's interesting. Now let's go down here and look at this other way. We're going to get negative 2/9. I mean, we know that's going to happen. The function is 2 over x. All right, so here we go. So once again, f prime of 3 is going to equal the limit as h approaches 0 of f of 3 plus h minus f of 3 over h. All right, so this is equal to the limit as h approaches 0. And now remember, our function was, and I have to remember myself, our function is 2 over x. All right, so this is going to be, watch what I'm about to do, 2 over 3 plus h minus 2 over 3. And now you're like, what happened to the h there? Well, I'm going to call that 1 over h, and I'm going to bring it over here to the side. Okay, and then hopefully we'll have an h that'll cancel out in just a second. All right, so so I've got the limit as h approaches 0. I need a common denominator here. It's going to be those two multiplied together since they share no common factors. All right, so my common denominator is going to be 3 times 3 plus h. All right, and then my numerator here then will be 6, because I got to multiply top and bottom of this by 3. 6 minus, and then 2, and I got to multiply top and bottom of this fraction by 3 plus h. So it'll be minus 2 times 3 plus h. And then times 1 over h, just to kind of avoid the fraction within a fraction thing. Okay, all right, so then let's clean this up. We see the 6's are going to cancel for sure, all right, but I'll just write one more step. You might be able to combine some stuff. All right, so my numerator, my first numerator then is 6 minus 2h. Okay, divided by 3 times 3 plus h. And then this dividing by h. Okay, so here we go. All right, so 6's cancel. All right, after the 6's cancel, this h will cancel with that h, and then we can substitute in. All right, so then I can substitute in because the h's are gone. And then so up top, I've got negative 2 once again, right? And on the bottom, I have 3 times, this is 3 because h is going to 0. All right, so since h is going to 0, that just going to be 3 times 3, which is 9. Yay, same answer as before. Okay. All right, we'll talk about that next video.